Everybody, this is Graveyard Shift Team Module 2 interview. My name is James.
Harrison.
Billy.
Erin.
All right, here we go.
James, what is the half-life of Wellbutrin?
The half-life of Wellbutrin is actually extremely long. It's 35 hours long. What makes this interesting is that it's one of those medications that has to really build up in your system to work. It takes sometimes anywhere from days to weeks to build up enough in your system that it starts to have an effect on you, which is really interesting when you think about it. It takes 35 hours just for half of it to leave your system. I also did acetaminophen in addition to the ibuprofen we started this project with. They're similar in half-lives. Ibuprofen is like 1.9. Acetaminophen is actually 2.5. What makes that interesting is if you have kids, especially really small kids, you have to, a lot of times, if they get a really high fever, the doctors will tell you to alternate between the two every 2 hours so they don't get a stomach ache. But it's kind of interesting to me that there's a decent difference there between the half-life and they still have you alternating every 2 hours.
That's good information to know. Thank you, James.
You are welcome. How does knowing the half-life of medication help us to know when it's safe to take a second dose? Harrison?
By knowing the half-life, we can tell how much of it will be left in our system based off when we originally took it. So by combining the remaining half-life with the total amount of the medication that we take from second doses, we can see how much will be in our system to tell if we took it then and there to see if it'd be a safe dosage. Billy, what is the half-life of children's ibuprofen?
The half-life of children's ibuprofen is approximately 1.95 to 2 hours. You start off on 100 milligrams, and it gradually divides in half as the hours go on. And the graph really shows that really well. Why is it important to know the half-lives of these medications, and what is the importance of a trend line equation in determining half-lives, and what is Euler's number?
I choose these medications, and aspirin in particular, because it's included in a medication called Fioricet that I take for migraines. And there is a very strict schedule as to when I can take certain medications at certain intervals. And the common thing that I have found between all of these, like ibuprofen, for instance, would be something that I would take as a first resort if it's not that bad. Then I would take Fioricet, followed by Imitrex. If it's something that goes on for several hours, even days, then I go to the ER, to the doctor, and get a shot of Toradol. But at that time, I cannot have ibuprofen or aspirin in my system because all three of them are actually anticoagulants, and that could cause massive internal bleeding. The importance of a trend line equation in determining half-lives is as your dosage of medication changes, a trend line equation allows you to insert any value, which in this case would be the number of hours, to determine the half-life or how much of the medication is left in your system. Euler's number is a transcendental constant like pi, and it's a mathematical representation of a number which you can plug into the trend line equation.
Great.
James, how are these things related?
Very good question. I'm not entirely sure. If you'll notice on these two graphs, you have two different lines here. One is for number of peritonitis, I believe is how it's pronounced, diagnosis in thousands, and the other is acres of GMOs planted in millions. And I'm not sure why they went with those two different units of measure. You have on one side, it's actually more like hundreds of thousands, but in thousands of the diagnosis. And on the other side, you have in acres and millions, and those lines do appear to be pretty close to each other. But I'm wondering if that was changed from acres in millions to acres in hundreds of thousands or thousands, if they would look the same. They might, but I'm just kind of curious why they went with those. Harrison, how can you tell if if a graph shows causation between two slopes of data just by looking at it.
Well, it's actually impossible to see if there's causations between two or more slopes of data just by the look on the graph. We can see if there's correlations to see if those slopes match up, but true causation will require us to research the subject and see what underlying factors might literally cause one of those slopes of data to directly affect the other.
Good job.
Billy, how does the table correlate with the graph?
All right. The table starts at 1990 and goes all the way to 2010. From years of 1990 to 95, there was no acres planted of GMOs. Now there was cases of IBS, but in 1996, we seen that GMOs were starting to be planted, and the graph shows really well that as the years go up, the number of diagnoses go up as well. Erin, how has the prevalence of genetically modified crops changed from 1996 to 2012?
As we know, correlation does not denote causation, but we can see in the graph that until 1997, there really was not a massive spike in genetically engineered or genetically modified crops in the United States. That's whenever we see a large spike in genetically engineered cotton products, which is something that's used commonly throughout household for both adults and children. Also, we see food products, corn, soy, which they seem to all follow a constant upward trajectory through the years up to 2012, which could present the probability of various diseases being a result of genetically engineered crops.
Awesome.
James, how much have deaths risen in the last year?
Quite a bit, actually. You'll see over here, especially during these age groups, some have risen by 100%, 300%, 117%. Now, the actual numbers don't appear that high, but still, when you go by percentage, there's quite a few, especially when you get down to the 70 and over. Ages 26, some 29. It could have something to do with the opioid crisis. A lot of mixing of drugs hurts that as well. And when you get into the older age brackets, you have a lot of people mixing medications with alcohol accidentally, which could lead to a lot of accidents. And it's when you look at the top with the road users, you also see it's been quite a bit of a jump in bicyclists and with drivers as well, but also with the motorcyclists and passengers. Bicycling, a lot of cities are putting in a lot of new bicycle areas that is right next to the actual car roads, which is probably a bad idea, especially at certain times at night. So that could account for some of this, but yeah, it appears to have gone up. Harrison, what does the information on this Venn diagram convey about the dangers of drug use when driving?
Well, a large portion of the accident causers in this study were under the influence of some drug. An even larger portion were the people who had no substances in their system at the time of record. The factors like tiredness and simply careless driving might play as much of a factor in causers' wreckage as substance users.
That's good to know.
Billy, which gender lost most lives and which age group had the most deaths?
All right. In the chart, it shows male and female drivers. In 2019, male drivers were 112 lives lost and 35 female lives lost. And as for the age group, unfortunately, the 70 years and over group had the most deaths. Okay, what is the meaning of bell-shaped curve, Erin?
The bins of the histogram cover data as far as the ranges of reaction times of impaired adults in seconds. And the normal bell-shaped curve formed by these bins shows that the data is equally distributed as far as the reaction times. There is a median reaction time for someone with a blood alcohol content of 0.08 of 2.4 seconds. And the median bin is 2.1 to 2.5 seconds. So the standard deviation is only 0.5 seconds.
That is interesting.
That is.
James, where do you fall on the BMI charts?
Okay, I am over on the men's side over here, this purple line. I'm just inside the second deviation on the lower end side. You'll see here there's a standard deviation of about 4.73. I did not put down what my actual BMI was. I forgot what it was actually. But my wife and daughter are just inside this first deviation. I'm not sure which one's which, but they're pretty close to each other as well. And so hopefully this will stick out here. But I'm just right outside the second deviation on the lower end side. Harrison, why is it less likely to find someone below the healthy BMI limit rather than someone above it?
That's because of the reasons behind this flip of data, where it's more likely to find somebody who's overindulging on fast or frozen foods than it is to find somebody starving in this day and age.
Very true.
Billy, what are the Z-scores of the selected people, and what is the probability of having a person with a lower BMI?
All right. The Z-score for myself is 0.2 with a BMI of 30. My sister has a BMI of 26 with a negative 0.3 Z-score. And Sean has a BMI of 24 with negative 1.1. The probability of having someone with a lower BMI than myself is 58%, whereas 42% with the higher BMI. And my sister, she has a 38% of someone having a lower BMI than her, and 62% higher. And then Sean has a 14% chance of someone having a lower BMI than him, and an 86% chance of someone having a higher BMI.
James, why isn't there more money going towards education?
Okay, you'll see here, this is the state and federal tax distribution here. You have 2% on the federal side, and on the Arkansas state side, you have K through 12 education at 14.6. They have 15 for higher education, which I'm guessing goes to state universities, probably some scholarships as well. One of the reasons this is so low is because a lot of money for schools comes from local townships and counties. Whatever little town you're in, whatever school district you're in, a lot of the money comes from just the local city taxes or county taxes, depending on how big or small your area is. Which is great, for example, if you live in Conway, which has a huge tax base. So you have all this money coming in. You do have a larger population of kids, but you do also have a lot more money to come in to fund for more books, or newer books. That's what I'm trying to say. Every kind of sports team imaginable. Conway actually has a bowling and a golf team, believe it or not, on top of all the other regular stuff you have. Not so great if you live in a place like McGee or Dermont down in the Delta area, where there's really nothing. You have maybe a gas station and half a dozen flea markets where businesses used to be. So you don't have that tax base coming in. You have a very impoverished area, and you're basically just living off whatever you get from the federal and the state taxes, which results in outdated textbooks, not to mention the fact you have teachers that are not sure when they're going to get their next paycheck, if they're going to get their next paycheck. completely stressed out. So, yeah, that's, you know, people talking. You talk about income inequality. People kind of roll their eyes a little bit, but that's really where it hits home about how this really affects people. Every study shows that an education, especially early on, is essential to being successful later in life. And impoverished areas just don't get the same chance that non-impoverished areas do. So I'm going to jump off my soapbox and go to the next one here. Harrison, how can a group possess negative wealth?
Well, if you take a look at the total wealth, say it's 100. If somebody owes $10 in debt, they'd actually have a negative 10% of the total wealth because they don't have any of the wealth. They have a negative amount of it.
That's frightening, actually.
Billy, where does most of our federal tax dollars go? Where does the least amount of our federal tax dollars go?
Okay, in the chart, you see that at 27%, Medicare, Medicaid, and CHIP, they take up a large portion of the pie chart, along with Social Security at 24%. And then the next would be defense and international security. The least is non-security international at 1%.
James, is this a good place to consider living in the future?
Depends on what you consider good. This is Steubenville, Ohio. It's where my wife grew up, actually. And just to give you an idea, this is the best picture I could find of Steubenville, and it was from an article about the opioid crisis in America, which is probably not a good sign. In this house I picked, it's in one of the nicest areas of town. It was $155,000. They actually have in downtown. They actually have houses for sale for like $9,000. So it might not be the greatest place in the world to live, although taxes are lower in a lot of places. The mortgage is really low because, you know, the area. Even though the tax, if you look at this bar over here, the taxes is by far the highest. It's not as bad as, say, I believe of the three I looked up, I think Denver, Colorado might have been the worst. Now, granted, we could probably live like kings if we didn't move there, but I'm not quite sure it's worth it. Which of these towns cost the most to live in, Harrison?
The most expensive town to live in is Hot Springs, Arkansas. But to do that, you have to add the total wealth, the total cost of all the household appliances, all the town levies, all that.
Okay.
Billy, which city is the cheapest to live in? Which is the most expensive?
All right, the cheapest city to live in is actually going to be Batesville, Arkansas. See, the house payment there would be $512, and the bills are a lot cheaper, along with a higher savings and lower taxes. The most expensive place to live is Panama City Beach, Florida. The same house that I could buy in Batesville is actually almost twice the amount in Panama City Beach, Florida.
Makes sense. All right. And that is our video this time around for Module 2. We will see everybody again in Module 3. So thank you for watching our video.
See you.
We will see you guys in the next one.